Welcome. So we are going to talk about the arbitrage pricing model. So this is for the exam preparation. So we already talked about the concept. So right now I'm just going to do the proof for you, right? So under APT, to prove APT under factor model, perhaps let's say you are given two factors. I mean like two assets, right? Asset I and J. Each asset has its own return, right? So let's say maybe the returns for I is gonna be and the returns for B I mean like for J actually. So we are considering only one factor. Now we want to build a portfolio, right? So to build a portfolio, it means we have to combine this asset one way or another, right? So how would we combine this asset? So let's say maybe alpha is gonna be the weight of asset I. If this is the case, then the returns of our portfolio is going to be equals to the weight or alpha. I used alpha. It's going to be alpha times A. Okay, I'm just going to write it fully. So I'm going to say alpha returns of 1 minus alpha returns of 2. This is not supposed to be 1. They are supposed to be I and J. I'm going to say J. Right. So if this is the case, you can then write it simply. You can say alpha is going to be equals to AI plus BIF 1 minus this, and then you're going to say AJ plus BJF, right? So how do you simplify this? So you can simplify this to write it down as factor, like a simplified factor model of a portfolio. It will have its own intercept. It's going to be alpha AI plus 1 minus alpha AJ plus the factor loading of this factor F. It's going to be alpha BI plus 1 minus alpha BJ, all multiply by factor F. So if our factor loading is 0, so you can just view this as your one big A and this as your one big B, right? So you can write it this way. So you can think about it this way, right? So anyway, if your beta is going to be 0, in this case you're going to say factor loading. If your factor loading is going to be 0, so this is if alpha BI plus 1 minus alpha BI is going to be equals to 0, then our portfolio so this thing should be a risk-free asset, right? It should be risk-free. Should be risk-free. I think I should write the way it should be risk-free. So you can like give it a name and say lambda 0, right? So if lambda 0 is not equals to the risk-free return, then there is an arbitrage. If lambda 0 is not equals to risk-free return, then there is an arbitrage. And if there's an arbitrage or opportunity, you can take advantage of it, right? But anyway, for which weight do we find that beta, I mean our factor loading, is going to be 0, the effective loading of a portfolio. We have already stated that AB, so this thing over here should be 0, right? So alpha BI 1 minus alpha BJ is supposed to be J. And then you can try to simplify this. You can say that alpha is going to be equals to minus BJ all over BI minus BJ. So this is your alpha. So you know that if our weight is gonna be equals to negative BJ over BI minus BJ, then our lambda 0 should be equals to risk free. If not, there is an arbitrage opportunity. Anyway, that's fine. We can move a little bit further, right? What we are left with for our return, our portfolio return, is basically lambda, alpha AI plus 1 minus alpha AJ. And in place of alpha, we can basically just we can basically put minus BJ over BI minus BJ. So this will make something like this. You will have minus BJ AI, this is supposed to be J, over BI minus BJ plus 1 minus alpha. What you will have, actually, you're gonna have BI minus BJ minus BJ. So what you'll have is positive BI, right, over BI minus BJ times AJ. I'm gonna say equals to lambda 0, right? So you can try to simplify this by taking this thing to the other side. So what you'll have left is minus BJ, or you can just write it better. You can just say BI AJ minus BJ AI is gonna be equals to lambda 0 BI minus BJ. So fine. Now we can start to group these things together, right? So I can say BI AJ minus lambda 0 BI, right? It's gonna be equals to, when this thing goes to the other side, it's gonna change the sign. You will have BJ AI minus BJ lambda 0. So you can find the common factor here, which is a BJ, and you'll be left with AI minus lambda 0. And also on the other side you have BI AJ minus lambda 0. So you will have AJ lambda 0 over BJ, right, equals to AI lambda 0 over BI, right? So you can just let C equals to this thing, right? So you can say this thing here, this price of risk, I don't know what I can call it, but let's just call it a constant C, right? So if this thing is going to be equals to a constant C, then you will have AI minus lambda over BI being equals to C, and thus AI equals to lambda 0 plus BI times C. Okay, fine. So now we know that the intercept for our asset I is going to be equals to lambda 0, where lambda 0, by the way, we are expecting it to be a risk-free return. If not, it will be an arbitrage. There will be an arbitrage opportunity, right? Where lambda 0 is going to be where our intercept for asset I will be equals to lambda 0 times the vector loading of the vector times a constant c, right? So from our returns of I, we know that we have AI plus BIF, right? So instead of just writing A, you can say lambda 0 plus BIC plus BIF. It's going to be equals to lambda 0 plus BIC plus F. And you can call this BI, you can call this lambda 1. So basically you can say let C plus F be equals to lambda 1, and this is what you will call your vector premium. You can say this is your vector premium. So anyway, so this is how you prove your arbitrage pricing theory. So when they ask you to find the equilibrium points, these are the points that they are asking you for. And the same theory applies even when you are looking at multiple factors, right? So when you have multiple factors, let's say maybe the returns of I, let's say maybe you have AI plus BI, F1, BI2, F2, right? Even if you have something like this, the arbitrage pricing theory will lead you to have your returns as lambda 0. Again, lambda 0 should be equals to risk-free return. Otherwise, arbitrage plus BI1, lambda 1, BI2, lambda 2. And you can calculate this vector premiums. So this one's going to be the vector premium of vector 1. This one's going to be the vector premium of vector 2. So the same thing can be said for other multiple assets, like for other vectors. So anyway, this is how you use your arbitrage pricing model to find the risk premium. So anyway, thank you. I'm gonna stop here.